Hello student, here I am going to show you the subject deep learning. In previous video I discussed about the deep learning, how it is work and what is deep learning. Now in this lecture I discuss about the next features of deep learning. So here first uh, I discuss the deep forward neural network. Deep forward neural mean that flow in single direction. You can see here is the input, and at the last here is the output. The data is flow from input to output. There is no loop or cycle exist. You can see the definition of deep learning, deep forward neural network. A deep forward neural network is a type of deep learning model where data flow in single direction from input layer through one more hidden layer to the output layer without any loop or cycle. It is a foundational model. It is a foundational model used for tasks like classification, regression, or pattern recognition. So this model we can use in linear data. You can use in linear data. Now the gradient descent. Gradient descent is a heart of deep learning. Gradient descent, you can say, they guide how a model adjusts its parameter during training to minimize error. It is like a driver that drive our model toward the better performance. So gradient descent is an optimization algorithm in deep learning that minimize the loop loss function by iterative adjusting model parameter. So there are three main type of deep learning gradient descent. Number one, batch gradient descent, stochastic gradient descent, and mini batch gradient descent. They are differ by how much data they use to compute the gradient. How much data they use. In batch gradient descent, use the entire data set in a, or we can say in a entire epoch. In a stochastic gradient descent, we use a single example, or in a mini batch gradient descent, use the small batches of data to train the system. Next, we will discuss the advanced optimizer in deep learning. Gradient descent also an optimizer, but here we discuss some other advanced optimizer in deep learning. So the optimizer, in other words, we can say that drive our model towards the better accuracy and performance. So you can say these are the driver of the model that drive towards the accuracy. So there are so many types of optimizer available in deep learning, but we discuss these five main optimizer. First is stochastic gradient descent with momentum. Second is Nastrop. Third is AdaGuard. Fourth is RMS Pro, mean that root mean square propagation. AdaGuard mean adaptive gradient descent. And ADAM is a adaptive moment estimation. ADAM stand out. If we talk about the Adam stand out as a true powerhouse, widely favored for its efficiency and adaptability. So next we discuss first optimizer known as SGD with momentum. Here we add some momentum with stochastic gradient descent. You can also see in this diagram. In this diagram, you can see SGT without momentum. Here and SGD with momentum is here. So SGD with momentum is a stochastic optimization method that add momentum term to regular stochastic gradient descent. Movement simulate inertia of an object when it is moving. That is the direction of previous update retained to certain extent during update, while current update gradient used fine tune and final update direction. In this way, you can increase the stability to certain extent, so that you can learn faster and also have the ability to get rid the local optimization. You can also see here. Here we take so many iterations to find the local minima, but here you can find the local minima in the less iteration. These are the advantage of stochastic gradient descent. Now this is a Nastrov accelerated gradient. You can It is also a refined version of momentum based optimization, because in the momentum based optimization, if you are going to find the global minima, here you need so many oscillation. So Nastrov accelerate gradient is the refined version of momentum based optimization designed to further smooth the smooth and speed up convergence. It does so. It does so while looking ahead at the future gradient and adjusting accordingly. They help to reduce the overshooting and improve stability. So you can also see uh, the formula of the weight updation. W is equal to W new is equals to W old minus Vt, where Vt is a beta, Vt minus T1. T1 is a previous velocity and Vt is a current velocity, and beta is a constant. Their value vary between 0 to 1. Epsilon is a learning rate, and there is a gradient. So you can see the advantage of NEC. It is reduced oscillations, number of oscillation. Or second one is faster convergence. Next, I discuss the adaptive gradient descent. So in adaptive gradient descent, all the algorithm that we discussed previously, the learning rate remain constant. So the institution intuition behind AdaGrad is can be different learning rate for the each and every neuron and for each and every hidden layer. So if you want to update the weight in each iteration, you need you need to update either gradient or the learning rate. The weight updation is totally depend on the learning rate and gradient. So the advantage of AdaGrad is learning rate change adaptively with iteration, and it is able to train sparse data as well. So here we I talk about the here I am going to show you the sparse data. Sparse data mean that the data there is number of zeros are available. Disadvantage of AdaGrad: if the neural network is a deep, the learning rate become very small number, which will cause the dead neuron problem. These are the disadvantage of adaptive learning. So next we will discuss RMS probe, root mean square propagation. RMS is a special version of AdaGrad in which learning rate is an exponential average of the gradient instead of the cumulative sum of squared gradient. Because if you are going to the cumulative sum, the value of VT are increased. So if the value of VT is increased, that means the learning rate value is very less. These are the disadvantages of the AdaGrad, due to which dead neuron problem is occur. So the second one, RMS probe. RMS probe is a special version of AdaGrad in which the learning rate is an exponential average. So here for the exponential average we use lambda. Lambda is a constant value. Or if you if I talk about the keras in a Python, then here the value of lambda is fixed to the 0.95. So the advantages of RMS probe: in the RMS probe, training rate get adjusted automatically. It choose a different learning rate for each parameter. The disadvantage is slow learning. Now the last and most useful technique or the optimizer is ADAM. ADAM stand out as a true powerhouse, widely favored for its efficiency and capability. So in a ADAM, short for adaptive moment estimation, is an optimization algorithm that build upon the strength of two other popular technique, AdaGrad and RMS. So how it is work? So now here I am going to show you there is momentum, adaptive learning rate and bias correction. These three are the main part of the ADAM. So now in the next concept of deep learning and this unit is autoencoder, are the type of unsupervised neural network used to learn efficient compressed representation. So here we will see now. Thank you.